Hello, welcome to Beginners Python and Machine Learning. My name to be don't know if yeah, sorry, it looked like my sound just dropped out there for a bit. We're looking for we're going to look at Python for absolute beginners, people who've never seen Python before. And so it's a live session, and one of the beauties of it is that you can ask questions as we go along, and the questions don't even have to be that closely related to what we're looking at, because we're really just trying to help people get into Python. YouTube chat is the live chat I'll be watching, and I'll also be looking at learning to code inside our Beginners Python meetup group and on Slack, and there's instructions below in the meetup event and in the YouTube description on how to join our Slack group. But anyway, if you're not in the Slack, then you can use the YouTube chat. Unfortunately, YouTube chat does get censored, so if you try putting things like URLs in there, it won't work. All right, now we're going to be looking at, Google Colab is a free service offered by Google to allow people to do Python programming using a virtual private server, and it's all free. And that means you don't have to install anything on your computer. It'll be using a slight variation on normal Python called interactive Python, which has everything in normal Python, plus it allows you to, which means it'll remember the values of variables and stuff between each command that you put in, and you can then change what your next command is going to be based on what the results of the previous command were. So that's great for learning, because you can just type in commands and see exactly what the results are going to be. So if you look below in the comments for this video, you'll see a link to Colab Research Google and this long code. It's also on the meetup event description, so either of those places you'll find the link. I'm not showing the YouTube page because then it would be what I'm actually broadcasting on. So I'm going to use this one. I'm going to click on the link, and it's going to open a new window, and what it's going to do is show you the notebook that I prepared earlier, but it's still in my account, which means it'll say changes will not be saved, because you won't be able to make any changes to it and save them because it's not in your account. So I recommend clicking this copy to drive button here, and that'll create a copy of it, and then you can make as many changes as you like. And that's the way to learn in Python, is to make changes, try things out, and see what the effects are going to be. All right. It's using private outputs, which I always do, so that we don't get to see the results until you actually run it yourself. So let's close that. And here we've got some release notes on the right, which just shows that on the 23rd of February, Google made some changes, and they upgraded all these packages inside their Python installation, which is good. All right, we can close that. There's an X here, so we can close the tab. All right, and so now we're just left with the notebook that we're going to be using today. The first thing I do is click on connect. Doesn't matter if you don't, it'll just take a bit of time later on to connect, and that'll set up a virtual private server just for you, and so you can do stuff in it, and that's just totally restricted to what you're doing. So our learning objectives here are, we're going to learn how to use interactive Python in this, what's also called a Jupyter notebook in Google Colab. We're going to concentrate on 3 data types, which are the list, the tuple, and the dict. This is short for dictionary. And we're going to look at how to do some scripting in Python, and looking at a bit of program structure. So how to do a conditional or a loop and a script. It's all very easy, but if you don't understand any of it, or any part of it you don't understand, just ask a question and I can go back over it in more detail. We've also got this link here to GitHub, which all our past sessions that have gone online, all my past sessions anyway, I've put up on this GitHub, so you can look through the past sessions. Then you can look up the links for YouTube and Colab and run through them again if at a later stage, even though you won't be live, so you won't be able to ask questions. So using Google Colab, this is what we're in. It's making use of Jupyter Notebooks, and which is making use of IPython. These notebooks are made up of cells, and the cells can be either text cells or code cells. And you can see these cells here have got a border around them. These are all code cells. The text cells don't have a border around them. They do. They only have a border around them when they're selected. So I can select that cell now, and it's got a border around it. And then between cells, if I hover in the middle here, I can add a new code cell or a new text cell. So the text cells are just a way of typing in some formatted text using the Markdown language. And the code cells is where we write our Python code. So that's where we'll be doing most of the stuff today. Okay, so I'll scroll down, and data type list is what we're going to look at first. So a list is a collection of various pieces of data. Now, I'm saying this is for absolute beginners. If you've done one of our other absolute beginner sessions, you would have seen some of the different sorts of data that we can have. We can have like integers and floating point numbers. You've got a decimal point in there, and strings. So they're characters. And strings, we designate as strings by putting quotation marks around them. So the quotation marks can be either single quotes or double quotes. They behave almost identically. Now we can put all these various pieces of data into a collection, and we can separate the piece of data with commas, and if we put square brackets around it when we're creating it, it will create a data type called a list. And I'm going to store that in a variable called LST, and then I'm going to print it out. So that's to run this cell. I just click on this play button, or you can see I can just press Control Enter. So if I press the play button, it runs the cell, which has stored this data into my variable called LST, and then it's printed it out, and you can see it's come out, and we'll see it's printed it out with, it's used different quotation marks, it's used single quotes, even though I use double quotes because they are pretty much identical. So that's how we create a list. Now, what can we do with this list? Now there's zero indexed, which means we can refer to each element using a numerical index, but that numerical index starts from 0. So if I say, what's the value at the 0th index of list, it will tell me it's the string SIX. And you can see, so that's 0, that's 1, 2, 3, 4, 5, 6. Now it's a little bit hard to get used to start with, but I'll give you a way later of remembering and show you why it's they've done it that way. Okay. Now you can also count back from the end. If you want to say what's the 1 second from the end, you can use a negative index here. So here we say list in square brackets -2, and that will say 1 is the second last item there, so it's counted back from the end. A useful thing when you've got a list of data is to know how long it is. And Python provides a built-in function called len, and it tells you the length of many different data types, and will tell you the length of a list in terms of how many elements are in the list. And so it tells us there's 7. So if we look here, we can count them: 1, 2, 3, 4, 5, 6, 7. Yep. So lists are very useful. It's a surprisingly simple way of creating this data structure. I remember doing Java and trying to create an array of values, and just the native way of creating it was I could never remember it. I always had to look it up. But in Python, very easy to remember, just using a square brackets and separating each element with a comma. Slices. So you might want to use a few different values. Say we want to use the 3 values between 2 and 5 in the indexes. Then we can do that by putting a colon between the 2 index values, and it will give you everything starting from index 2 going up to but not including index 5. And the easy to remember way to work out how many items it's going to return is going 5 minus 2 equals 3, so it's going to return 3 elements. So let's have a look at LST 2 to 5, and there they are, 4, 3, 2. So what I do to remember how these index positions work is I think of the index positions as between the data. So you can see here is our data, 6543210. Now I've put the index positions underneath here on this in this comment. These lines are comments, by the way, because they start with a hash, so Python just ignores them. So okay, 0 to 1 is this value, 1 to 2 is this value, and so we've just asked for 2 to 5, and so it's given us 4, 3, 2. So it starts at 2 and goes all the way up to, but doesn't include the value 5, index value 5. And similarly, the negative indexes work the same way. Now obviously we can't refer to an index 0, we never would want to, so it's because 0 is not a negative number, but there is a way using slices where we can, if we just leave the value after the colon blank, it will take us all the way up to the end, so we don't have to say the last value or know how long the list is. All right. Now, in interactive Python, I can just type a variable name like this, and it will display what the contents is. I think I've probably done that a couple of times already. Yes, I have. So that just tells me what's in it, LST. Then you can't do that in normal Python. If you wanted to display it in normal Python, you'd have to use the print function. So you say print, open parentheses, LST, close parentheses. The other aside that I will say is, why didn't we call our list LIST? And the reason we didn't do that is because there is a function, a constructor for making list objects, which is called LIST. Now if you call your variable LIST, it will blindly override the built-in constructor that makes lists, and so you'll find that you'll no longer have access to that. So I recommend don't ever call your variable LIST, and so in this case I've called it LST. Okay, moving on. Now there's a syntax that allows us to change the value of one of the items in our list. So here we got the list, string, integer, float, string. Now we want to change this float to a string, FOUR. And we can do that using this index notation. So we put the index in square brackets and we say we want it to be assigned to the value 4. Now tell us what our list looks like, and we can see there it's now, rather than being 4.0 as a floating point number, it's a string, FOUR. There's another change we can make to a string, a list, is to delete a particular object in there. So the one at index 4 we can delete, in which case what is left, we've deleted this one here from it because that was the one at index 4, and now what is left is just this list without the value string TWO. Now we can add a new item to the end of a list, and we use the append method on our list to do that. So we say we have our list, we say dot append, and that runs a method on the list itself. So it's like an object-oriented way of calling the method. And we want to add an object, and we want to add 1j to it. So let's have a look at what our list looks like after we've appended 1j. And there it is. You can see the 1j at the end. Now you might be wondering what 1j is. It's not a string because it doesn't have quotation marks around it. It's a complex number, and complex numbers are based on the square root of -1, which of course you can't take the square root of -1, so it's called an imaginary value. And so they've used j in Python to and as long as your j comes straight after a number, it'll be interpreted as a complex imaginary number. So that's how we say 1j is a complex number. I love using complex numbers myself, but they are a fairly advanced mathematical concept. Okay, data type tuple. Now a tuple is very much like a list. In fact, the only difference between it and lists is that tuples are immutable, which means you can't change it in place. And the way you define a tuple is the difference between defining a list and a tuple. In a list we use square brackets around it. In a tuple we use parentheses, and then we put commas between each of the items in the tuple. And so when we print it out, you'll see that it prints it out with parentheses as well, so it's clear to everyone that it's a tuple. And once again, we can refer to items inside the tuple by using the index notation, and it's the same index notation. So we do square brackets, the same we did as in list, and put the index in there. And the reason we don't use parentheses here, parentheses are used when you're calling functions and constructors, but when we're looking up an index of a collection, then we will use square brackets. So tuple index value 0 has the object value SIX, the string. Okay, now I've set a challenge here. What is something you can do in a list that you can't do with a tuple? So I've left a blank cell here for you to start typing in things and trying them out. Now, so like here you could type in, tell me what the value of TPL currently is, and it tells me that it's this. I say, okay, tell me what the value at index 1 is, and it tells me it's running a bit slow for some reason. You can see up here, this is our, and up the top right, we're using 1 gig out of our 12 gigs of RAM, and we're using 21 gigs out of the 107 gigabytes of storage that Google have given us for free. Okay, for some reason the connection was a bit slow there, but it's come back to us, and value at index value 1 is the integer 5. Now I'm just going to I've done a whole bunch of different expressions that we are going to do on tuple, and I've done them down below as an answer to this question, but I've put them in a print statement and an F string, so that it shows what the expression is and what the result of the expression is. So the way an F string works is we enclose the expression in to make it a string. We put an F out of the front of the string, and once we put an F out the front of the string, then we can enclose the expression in curly braces. So in an F string, whereas there's curly braces, it'll evaluate the expression and then store the result of that in the string. So we see, and it's going to leave it in a string. So now if I put a print around that, it'll get rid of those quotes because we don't really actually need them. And so I'm now calculating that expression and printing out the result. But I want to know what that expression is. Now in the past I used to have to write TPL1 equals, and it would print out the expression and what the result of the expression is. But now in F strings they're a bit more advanced, and people wanted to do that so often they've created an equals operator. Then it will actually print the expression and an equal sign and then the result of the expression. So that's pretty useful. So hopefully you can understand what that means, and now let's go through and look at some of these expressions with our tuple and see which ones work. So first of all, we'll check what our tuple is, and there it is, there's the values in our tuple. Now let's do our checks on what the results of using a positive index are, which is what we did with our list. And they all work exactly like it did with the list. So accessing by positive index, that's a tick. It all works well with tuples as well as lists. Similarly, let's look at negative, using a negative index, and I've got a couple of examples there. And -1 is 0, -2 is 1. So that's all good too. All right, let's find the length using the built-in len function. So the length of our tuple is 7, just like the length of our list was 7 before. Let's try some fancy slicing. I've got a few more examples of slicing here than we did for the list, but you can try all these with your list as well. Let's see how they work. So 2 to 5 gives us those 3. All up to 4, which gives us all the ones up to but not including 4, index 4 gives us those. So that's index 0, index 1, index 2 and index 3. From index 3 onwards all the way to the end, and that's what I said before, if you leave the number after the colon blank, it'll take you just to the end. Then that's the result. Here's one I didn't describe before. You can use 2 colons in your slicing, and the first number is your start, the second number is your finish, and the third number is what step you want to use as you go up. Now we've left the finish blank, which means go all the way to the end, but we're going to go in 2s. So here we go, 5, 3, 1 are the values. So that's index 1, index 3, index 5, and there's nothing in index 7. Similarly, when you've got 2 colons, you can step backwards by putting a negative step in there, and so this reverses our tuple and takes us from the one end, which will be the last because it's a negative stepping, all the way up to but not including 1, and that gives us those values. Okay, any questions so far? I hope you're running these yourself, and maybe type in a couple of extra ones yourself and see what they look like. So for example, we'll just create a new code cell here. The next one we're going to be testing is assigning a value to an element inside the tuple. So remember we did this for the list. We said we want the element at index 2 to be an F. So if we remember, I'll create a new one here. If you remember what our tuple is, It's these ones here, and we want the one at index 2, so 0, 1, 2. We want to change that from the floating point number 4.0 to the string capital F. So let's try that. We'll run that, and it gave me a type error. Tuple object does not support item assignment. So this is what I said before about the tuple being immutable. You can't just change any of the items inside the tuple. Alright, now I don't like putting a command that's going to fail inside my notebooks, because then if someone decides to click on run all to run all the cells in the notebook, it'll go all the way to the first error and stop there, and the rest of the things won't get run. So I've put the code into a try except. So what that does, I'll just do it, this one here. We try to run our code, and if there is an error, then it will print what that error is. And if there isn't an error, then we go, oh, let's print what our tuple now looks like. So if we run this, now we don't get all this trace back and error message and a red play button there and an exclamation mark here. It all works, but we just handle the error a bit more gracefully, and we say when we tried to assign an F to tuple 2, we received an error, and the error was tuple object does not support item assignment, which is the same as this message here. Alright, so let's try that on several different things. So item assignment with a positive index, item assignment with a negative index, and deletion of a element of our tuple. So there we go. Error here, tuple object does not support item assignment. That happened twice for the first two, and tuple object does not support item deletion. So there are three things, and that's all because tuples are immutable. Alright, so you might ask, why use something that's immutable? It's obviously it doesn't do as much as a mutable one, and there's some reasons for that, which we will get to a bit later. But are there any workarounds? Say I really want my tuple to have new values. How do I put new values into my tuple? And the way you do that is you construct a new tuple with the values that you want, and you store it in. You can store that new tuple into the variable location that well, it's not stored in the location, it's just the variable now points to this new value. So if I run this bit of code, you can see I've now got a tuple. It's a different tuple. It's got the F there instead of the number 4, and I've constructed it from the old tuple, and it is now what tuple refers to. Okay, so now I'm going to describe why this is important. If you've got a variable that's referencing a tuple, you can be confident that the values won't change within it. But if you've got a variable pointing to a list, then you don't know that somewhere else in your program the values might change, because something could change the values in there. So that's the difference between using a mutable variable and an immutable variable. So here's an example. We've got a list 1, 2, 3 and a tuple 1, 2, 3. Now we're going to create a new list, which is just equal to the first list, and a new tuple that's just equal to the first tuple. Then we're going to print them out. Then we're going to do, we want to do this change. We want to change the 2 to a 4 in both cases. So for our list, we can do it this way. we can use item assignment based on an indexed value. So we say the value at item index 1 we want to now have the value 4, and for our tuple we know that won't work, but we can construct it this way, where we have all the values up to index 1, our new value for index 1, and then all the values after that index 2. And now we'll look at, so we've just changed list 1 and tuple 1 here. How has that affected list 2 and tuple 2? So let's run the code and see what happens. So before the changes, list 1 and list 2 were the same, and tuple 1 and tuple 2 were the same. Now after we've done those changes, list 1 and list 2 are still the same. So we didn't say anything about changing list 2, but because list 2 was pointing to the same list that list 1 was, when we changed list 1 in place, list 2 got that change, and now the second item in list 2 is now a 4 rather than a 2. But on the contrary, in our tuples, tuple 1, we created a new tuple, which is now 143, but our tuple 2, which was originally pointing to it, is still pointing to the original values of tuple 1, which is 1, 2, 3. So we know that even though anything we've done to tuple 1 won't affect the values that are stored in tuple 2. Now that might be a fairly subtle difference at this stage of your learning Python, but it's a very useful one to know, why that there exists a reason that you would use immutable variable types rather than mutable, and it actually saves a lot of unintentional programming errors. So my recommendation is to actually use immutable variable types whenever you can, and then only use the mutable ones when you really need that functionality. Okay, moving on. So we can convert a tuple to a list by using this list constructor. So it's list followed by parentheses, and then inside the parentheses we put something that is going to create the list. And if we put a collection, and a tuple is a collection just like another list is a collection, it will make a single collection from that. So here we're going to have our variable name is called list from tuple, and our tuple is the one before that we had, which is this 65F3210. So let's create a list from that and display it, 65F3210. There we go. So this is this constructor here that constructs lists. We would lose if we called a variable list. That's what I wrote here. This is why you should never call your variable name list, because that would override that constructor. And similarly, there's a tuple constructor that will convert it back. So you can see now it's got the parentheses there when we display it. We didn't actually store this one in a variable anywhere, so it's now lost, but it's that's how you do it. Okay, let's have a look at some Python programming now. So up until now, we've just been using Python as a calculator, just been storing values and rearranging the values. But we want to create a Python script, which is just several lines of code. They will operate in order, and we're going to make the code branch based on a decision that it makes as it goes along. So it's doing something clever. It's going to roll a die and see what the number that comes up with it, and if it's an even number, it's going to say you rolled an even number, and if it's an odd number, it's going to say you rolled an odd number. So this is our code. We're going to use this function here, randint, which is finds a random number between 1 and 6 inclusive, which is a bit unusual for Python, but anyway, it's good for this. And it's in the random standard library. So to use it, we have to import random.randint. So if we don't import random, then we can't get access to this function. And we're going to store the results of that. So it's going to be a number, one of the 6 numbers, and it's going to be stored in this variable called die_roll. And then we're going to divide it by 2, and using this modulo operator, we're going to look for the remainder. If the remainder is 0, then it must be even. If it's 1, then it must be odd. So let's run it once and see what we get. We rolled a 3, which is an odd number. Yep, that's correct. Let's try again. A 4, which is an even number. A 3, which is an odd number. A 6, which is an even number. Okay, so our code seems to be working. All right, challenge 2. Roll 2 dice and report whether the first die rolls a greater number than the second. Okay. So we can do that with we'll create our first is going to be random.randint 1 to 6, and our second one is going to, so they're the two there. AI's filled in that for us, and we want to report whether the first one is a greater number than the second. Okay, so if D1 is greater than D2, so that's our so the structure of an if statement is we start with if, and then we put in what's called the conditional, and that's an expression that will return a true or a false, and then we have a colon, and the colon means start a code block of all the things that we want to do if that expression is true. All right. Now, a code block is, we would always indent. So you pretty much always see, if you see a colon here, it's going to, the next line is going to be indented. And this is how Python keeps track of where your code block starts and finish, by the indentation. And that's slightly different to any other programming language I've tried, which will use things like curly braces to signify where the code blocks are. But it actually makes the code very clean and easy to read. All right, so that's if it's true. And now the next thing we want to do is do an else statement, and what to do if that's not the case. So we can still write what we rolled, and that now it's less than or equal to the second die. Okay, and it looks to me like AI got that right. So let's try running the code that AI has mostly written for us. So we rolled a 3 and a 2. The first die is greater than the second die. So it's run this bit of the code here. If we run it again, we roll 6 and 6. The first die is less than or equal to the second die. So in our else statement, we've actually taken 2 conditions. We've taken equal to and we've taken less than. Exactly what we want. So in the solution that I provided, we can see that there's another thing that we can do, which is else if, and we can put another condition in. So we've got 3 options here. The first roll is greater than the second roll, first roll is less than the second roll, and the third option is they are both equal. And so you can see this is the code block for this colon and this condition. This is the code block for this colon and condition, and this is the code block for everything else. So let's run that. So 6 and 1, first is greater, that's good. 4 and 6, first roll is less than. 2 and 1, greater. 5 and 1 is greater. 1 and 5 is less than. 1 and 1, they are both equal. So that's working for our different cases that we tried. So feel free to change this around if you understand it. Now you can see here I've put both dice rolls into a single tuple, and then I can refer to them by the indexes, or as in this case up here I've just used different variable names. So you can do it either way for this particular example, but often tuples will be more flexible, especially if you've got more than just two values. One question that you might come across: how do you create a tuple with just one value in it? So if I say, and then display t, it just displays a 3, and that's because it looks in here and goes, well, there's just one value, so you must talk. What you think about parentheses is that it's using the mathematical value, the mathematical significance of parentheses, which is just do this expression first. When the expression was very simple, it's just the value 3, so it's just stored the value 3 into t. So if you want to create a single value tuple, then you have to put a comma in there as well. And you can see that now. We'll have a single value. So what about a tuple with no values in it? If we run that, that works. That's a tuple with no values in it. The other option is we can just call a constructor, and that will do the same thing. Okay, challenge 3. For an element of a tuple, say whether it's a string, an int, or some other type. And so the way you check for a string is you can use this type function of our value in the tuple and compare it to str, which is a string. That's one way to see if the type is exactly a string, or you can go is instance of string, which means it'll be true if the type is a class of string, has a class of type string, or it is a subclass of type string. Often it's probably safer to use is instance, but in this case we are interested in whether it's exactly a string or an int. So I've got the solution here. Let's do it for each element of the tuple. Okay, so we'll do it. We'll have our index, and we'll say index 0, and we'll say we're looking at the tuple at index 0. If tuple I and we want the type of it, then we will print that it's a string. Else, if tuple is an int, print it's an int. Print other, and we will print the value of the tuple and the type of it. So if we run that, we say the value at index 0 is a SIX, and it's a string. And then we can change this and run it. The next one is a int, and it's 5. And at value at index 2, it's a string, the letter F. It's a string, the number 3. It's a string, the number 2. It's a string, the number 1. String number 0. And there is nothing at index 7. Okay. I think, yep, That'll do. Alright, so that's one way of doing it. You see how laborious it was to go through each one of those one at a time. So is there a better way of doing it? And this is one of the advantages of using an index, is that we can go through. In fact, in this case, we're not even going to use the index, we're going to use the for loop. And the for loop in Python can go through, can look at a collection, some sort of sequence, and just each time it runs through, it'll take the next value of the sequence and put it in the variable a, and then the rest of the code is the same. So if we run that, we get a, first time through it's a string, then an int, then a string, and we didn't get any others. So let's add our complex number as another tuple. And it comes through as another, which is a 2j, and the type of that is a complex number. I forgot to put in here I equals 7. I don't need this anymore because it's now been updated. Yes, 2j. Okay, so let's run solution 3 again with the same answers, and once again it gives it now goes through this 8 times, 0 to 7, and finds the value 2j is of type complex. Okay, yeah, so that's repeating the same code block over and over again. So this is really programming. So we've done a for loop, later we'll use a while loop. We want to repeat the same code block many times, so we use loops. Here's another example. So here's a tuple containing 3, 2, 1, and we just print those 3 numbers, 3, 2, 1, each one on a new line. A while loop is like a cross between a for loop and if statement. It has a condition in it. So it says while some condition. While this is true, keep looping through this block of code. So when you set that up, it's pretty important that there's something inside that block of code is going to change the evaluation of this condition. Otherwise you'll have an infinite loop. So we want to make sure there's something in here which is going to change the value of counter. So every time we go through this loop, counter is going to increase by 1. That's what this means. Counter plus equals 1 means take the value of counter and add 1 to it and store the new value in counter. So counter is eventually going to get greater than 10, in which case this is going to stop running. So here's our counter. It starts off at 0, 0, 1, 2, 3, 4, up to 9, and then when it's 10, it gets to here. While counter is less than 10, it no longer is, so it doesn't run the code block anymore. So that's a while loop. So that's another sort of loop that you can use. Okay, challenge 4. Write a program which prints every number from 0 to 20 as digits and its name in words, as well as whether it is even or odd. You can use the following table. Okay, so I've created a tuple here which has got all these strings in it, 0, 1, 2, 3, 4, and they actually, if I look up the index of any one of these, is going to have the name there as well. So index 13 is going to have THIRTWEN. So I better run this cell to make sure that variable gets stored with the name. And now I'm going to loop through it. Now I could create a counter equals 0. I'll go through each of the numbers, and I'm going to print my value for counter, my value for A, and my value for whether it's even or odd. Okay, so let's go even if counter %2 equals 0, else odd. There we go. That's a bit complex for you, but let's see if it works. And the next thing I want to do is then increment counter. Okay, so counter 0, 1, 2, 3, 4, 5 up to 20. That worked. My pulling the next number out of the tuple worked. 0, 1, all in text up to 20, and then even or odd, even, odd, even, odd, even, odd, even, odd. Okay, so you can see here I've put an if statement on one line as an expression. So that's how you do a, that's called like a ternary operator. You've got a one value if it's one thing and another value if it's the another, and the expression. So there's the three parts to the operator there. It's a bit clumsy doing this counter and counter plus equals 1. Turns out that's a thing that you want to do quite often. So Python improves it easier, and it's called enumerate. So there's enumerate for I, value in enumerate numbers. So what that does is it takes a sequence like numbers, which is just a tuple, and then for each one of those it assigns a value to it, an index. It is an index, yeah, and then so it will return pairs of values for each value in numbers, and the first item in the pair is the index, and the second item in the pair is the value. So that saves us a bit of code there, having to use counter, and so we can run that. I've done the even odd calculation in a few more lines of code this time, but then when I've printed it out, I've done some nice formatting so that the values line up more easily. So I've used these F strings with formats. When you put a colon, then you can put a format in there. I've just used a simple format being the number of characters wide the column's going to be, and so that's given me these nice lined up columns in my table. Okay, the problem with this code is it doesn't scale well. Now we could make a tuple with 100 elements for the numbers 0 to 99, or we could have two tuples, one for the first 20 numbers and one for the tens. So in the tens we could have 20, 30, 40, 50, 60, 70, 80, 90. So let's run that. So if I equals 30, then we've got to do this calculation. 30 integer or floor division 10, that gives us 3, minus 2 to give us 1, and go to index value 1, and that turns out gives us the value thirty. All right, so but that's a bit convoluted and probably difficult to understand. So fortunately there's another data type called the dictionary, which allows us to provide both the index value and the value, so it can be used like a lookup table. So then, you know, the value 20 can look up TWENTY, the value 30 can look up THIRTY. So for I equals 1, then we can I equals 30, then we can print out the value of I and can easily get the value of 30 from that. Now the keys, here we've used integer keys, but you can also use strings as keys. So here's another example using the phonetic alphabet. And we're going to create a dictionary that's got all the letters of the alphabet and their phonetic equivalent, and then we're going to convert the word Python into its phonetics. So it's Papa, Yankee, Tango, Hotel, Oscar, November, if you're using a radio and trying to spell out Python. That's how you would do it. So you can see what we've done here in our for loop. Remember I said this could be any sequence. Well, a string is actually a sequence as well. It's a sequence of letters. So we can say for letter in Word, and it'll just go through each letter one at a time, and then it can use that letter in the index of our dictionary and print it out. And then the other thing I've done is I've said when it does the print statement, don't print a new line. At the end, just print a space. And so it's printed it out, left a space, and then printed out the next one, left a space. And so these have all printed out on the same line. And then I finally printed a new line so that it will go down to the next line. All right, so our last challenge, write a Python script to write a number in words for any number between 0 and 99. And we have to consider the following conditions. If the number is less than or equal to 20, if the number is greater than 20 and divisible by 10, and the number is greater than 20 and not divisible by 10. All right, so let's look at those three examples. So I'm going to create 3 code cells. For number in range. We haven't done range yet, so we'll use a while loop. Number equals 0 while number is less than 100. Number plus equals 1. All right, so that gives us a loop that will print out the numbers 0 to 99. Let's run that, and there we go. The numbers 0 to 99 have just all printed out. Yep. Okay, now let's look at the 3 cases individually. If the number is less than 20, if number is less than 20, print, we can look up our numbers variable, which we did up here. Okay, and we'll do less than or equal because it said let's do less than or equal. So print number, we don't need this print number or anything. Okay, so let's run that. So 0 to 20, all we have to do is that. Okay. Now I'm just going to comment that out, and we'll do another one. If the number is greater than 20 and divisible by 10, well, that's the code. Print the number, and then we can look up the dictionary for that number. Okay, and there we go. 30, 40, 50, 60, 70, 80, and 90. And then the last case was, why don't I just comment these out because you don't really know what pass is. I'm just using control /, control /, which is the divided by sign, and that comments those out. And the last case is if number is greater than 20 and not divisible by 20, not divisible by 10. In that case, we're going to print out print the number, and then we're going to print the tens of the number. Well, we can't do the tens of the number because the number could be something like 21, so tens is not going to give us that value. So what we have to do is we have to split the number up into its tens and its ones. So let's find the ones first, and that's going to be the number modulo 10, and then the tens is going to be the ones, the number minus the ones. So if it's 21, number modulo 10 is going to give us 1, and then tens is going to be 21 minus 1, which is going to be 20. So then we can look up the tens. Oh, I can't call it tens, can I? That's why I can't call it tens. So I'll call it tens value. And then we've numbers using the ones value. Okay, and we don't need the else at this stage. So that's pretty close. So 2-1 is 21, 2-2 is 22, 29, 31. We do need a dash in between those. So probably the best way of doing that would be using an F string. So we'll have the first expression followed by a dash, followed by the second expression, close that expression, close the string, and there we go. Now that was one way of doing it. The other way, and that's because the standard separator in a print function is the space, as you can see from that little help description I've got there. The other thing is I could have just changed what the separator was. But anyway, that gives you an idea of how to construct. All three cases work. Now we can put all of those together as we've got in our solution down here. And I've introduced the range function here, which is a quick way of getting all the numbers starting from 0 up to, but not including the final number. And then I've looked at our three conditions. The first condition, rather than going, is it less than 20, which is hard-coded, I've gone, is it less than numbers? So I'm going to assume that numbers is going to give me all the first values up into a certain value, and if it exists there, then I'm just going to use it. And then I'll use else if, check if it's divisible by 10. If it is, then I can just go straight to the tens. Otherwise, I have to split up the ones and the tens, and I can then, and I've used the F string the same way here. So let's run that to check that it works. And yep, that works. So 20, 21, all these teens worked, yep. And then 30, that works. It's not 30, 0, it's just 30. 40, that works. So yeah, they've all worked. Now, I haven't got any questions so far. I hope you enjoyed the session. I hope you learned something from it. That's it for now. We're going to try to organise another in-person session, probably with 2 topics next time. So keep an eye out for that one. And also we'll probably be doing some more advanced online ones as well. So thanks for watching. Hit like and subscribe if you like these sessions, and you can also sign up to Meetup if you want to be notified when these things are coming out.